Hello and welcome to Learning Programming AI. In this series, we are going to learn the science of AI. We are going to learn programming. We are also going to look at how do we build some real world applications. So do subscribe to the journey. Check the links in the description. You can download some of the notes and slides used in these talks. So let's get started. We looked at what language models are and how do language models become large language models. We basically train them with vast amounts of data. And how do large language models also become foundational or foundation models, which are basically models we use to build more complex applications or maybe train it for more specialized data, all sorts of possibilities. Now let's look at what exactly happens when you are building a model. So at the core of every model is a process called as tokenization. So if you look at an English sentence, it's made up of words, it's made up of relationship between these words, and so you can break these words into tokens. So let's talk about this process. So a language model basically captures the statistical structure of how words are related to each other. For example, if you look at a sentence like my favorite color is blue, right? There are like 6 words in it. My favorite color is blue. And the language model will try to identify each of these words. But here is the fun part. So if we look at each of these words as a token, then there's going to be a huge amount of words that the model has to learn and retain it as part of the model structure. So the fun part is if you look at a bunch of words like walking, talking, sleeping, there is something common across them. So we have walk and we have the process of walking. We have sleep, process of sleeping. Talk, talking. So if you look at the ing part of the word, that is common. So if we can train or create a tokenizer in such a way that it can split the word at ing, this repeating piece, we can use much lesser number of tokens to represent all the words in a sentence. So if you remember, we talked about vocabulary last time. So a model is known by how many unique words it knows, and that is the vocabulary of a model. So just like any human, when we learn a new language, we basically learn as many words as possible from that language, so you can express yourself very well. The more number of words you know, there are much better ways for you to express a concept or an idea or whatever it is you're trying to say. So similarly, the bigger the vocabulary, the model will understand the content or data you give it much better. But in order to conserve resources, maybe memory, CPU, all sorts of things, what we can do is we can build our tokens in such a way that we look for repeating parts in a word and separate that out. So the common thumb rule is that we can use about 3/4 of number of tokens to represent a sentence. So if you have 10 words in a sentence, chances are you will probably need only 3/4 of those as tokens. The rest of it can be constructed from the tokens itself. So if you look at some of the popular models, for example ChatGPT, that has around ChatGPT 4. So that has around 100,000 tokens, roughly around 100,000 tokens. So similarly, if you take a newer one, it could be much higher, it could be 200,000. So the more number of tokens you have, the model becomes richer in trying to understand the world it is given to that. So the token is basically the smallest unit that the model can understand. A token could be a whole word, it could be part of a word, or even a small punctuation. This process of breaking down text into these units is called tokenization. So this complete set of all tokens is also called as the vocabulary. Now let's look at how some of the models use this vocabulary. Okay, I mean how they build this vocabulary. So there are a couple of ways to train models. You can just give it all the text in a document and it will try to break them into words. That is one way to do that. But there are very specific techniques to basically train these models. One of them is called masked language model. The other one is called autoregressive model. So let's talk about the masked language model. A masked language model is used to predict a word anywhere within a sentence. So it is bounded by the words before the missing piece and after the missing piece. So for example, let's take a sentence like I dash my homework. Now this dash could be I finished, or I carry my homework, or words like that. So a masked language model will try to predict or guess the right word that is bounded by the other two words, and it fills in the most suitable word. So since it has seen a lot of documents and a lot of uh, data, the model is probably going to predict the word as finished and say that I finished my homework. So similarly, we have something called as an autoregressive model, which is very popular because we use it a lot more than masked language models. Autoregressive model is something that will predict the next token in a sequence. So you take a whole sentence and ask it to predict the next word that would follow in this sentence. The autoregressive model can predict the next particular token. The beauty of this is it can predict that token, use that as the new sentence or context, and then predict the next token. So it could add that, create a new sentence, and predict the next token. That's exactly what ChatGPT does, right? This simple ability to predict comes as the generative AI capabilities of a model. Now, the next time you chat with AI or you see it writing something, you can very clearly understand that what it is doing is just predicting the next best token that fits into this sequence of words. See you in the next episode.